Howdy guys, so in this video we're going to look at the standard normal distribution. Now I've already looked at a normal distribution, but this one's a standard, and you'll see what I mean as we go through this. Okay, so when we talk about the standard normal distribution, you're going to see this Z come up. And we're going to talk about the Z distribution, and what that means is the standard normal distribution. So you might see either one. Now the thing to note, and I'll read through this in a second, but the main thing to note with the Z distribution or the standard normal distribution is your mean is always 0 and your standard deviation is 1. So as you can see, all of these numbers are really nice and round, I suppose. You've got -3, -2, and all of that sense. So if we go back and sort of read the top, so the probability density function for a Z distribution is this wonderful thing. Probably won't do too much of it, but just know that it exists for Z between -infinity and infinity. If X is an observation from a normal distribution with mean mu, standard deviation sigma, the Z score of X, so Z is equal to this. So it'll be the mean, the observation, whatever that number is, minus the mean divided by the standard deviation. Is the number, now this Z, as I said before, gives you the number of standard deviations X is from the mean. So for example, if Z is equal to 1.84, then X is 1.8 standard deviations to the right of the mean. So if we have a look at this situation down here, so if we've got 1 and 2, what this means is X here, if Z is 1.84, fits somewhere in amongst here. So that's 1.84. Okay, if Z is equal to -0.273, then X is 0.273 standard deviations to the left. So that'll be somewhere in here, for example. So the diagram alongside shows how the Z score is related to the general normal curve. So if we're just talking about any sort of general one, we've always got the mean plus the standard deviation plus 2 standard deviations plus 3. But when we're talking about a Z distribution or the standard normal distribution, we've got 0 in the middle, and then we go 1, 2, 3, or -1, -2, -3. So I hope that makes sense. And they're very closely aligned, but they make things nice and easy for when we're also trying to find other stuff, which I'll go through in a second. And by a second, I mean in the next video down the track. Okay, so this kind of compares between a normal distribution and a standard normal distribution. So if we look along this side here, we're kind of just looking at our normal distributions. So here we've got P is X is greater than or equal to X1, where on this side we're talking about the Z distribution or the standard distribution, and this is Z1 here, and this is 0, because we know on a standard normal distribution the mean is 0. So remember how we talked about some notation before? If we're talking about just a normal distribution, we write X. This is a tilde, that's what it's actually called, N, and then we've got the mean and the standard deviation squared. Or if we're talking about a Z distribution, we still use the N, but we've got 0 and 1, because we know that that's the same for every Z distribution. Now corresponding Z values, so Z1 would be X1 minus the mean over sigma and Z2, and we could do that to find what they would be when we start equating things. So these are equal, and we find Z1. So we find this figure here, or this figure here, by using this equation. And we'll go through some examples on how it works to show you what we mean. But I think the thing to note is that Z scores are particularly useful, as it says down here, when comparing two populations with different mean and standard deviation. However, these comparisons will only be reasonable if both distributions are approximately normal. Okay, so here's an example. So Kelly scored 73% in her history, where the class mean was 68% and the standard deviation was 10.2. So let's go and highlight that information. So Kelly scored 73% in history, where the mean was 68 and the standard deviation was 10.2. In mathematics, however, she scored 66%, and the class mean was 62%, and the standard deviation was 6.8. So in which subject did Kelly perform better with the rest of her class, assuming the scores for both subjects were normally distributed? So what we need to do is we need to go and find Kelly's Z scores. So if we talk about Kelly for history, or z-score, history. Now, if we remember that formula, so z was equal to x minus the mean divided by the standard deviation. So we're going to have z is equal to x, so x in this case was 73, minus 68, which was the mean, divided by the standard deviation, which is 10.2. Now, if you put that in your calculator, you should find that you get a lovely answer of 0.490. So imagine we had a normal distribution here with the mean 0. She's kind of around about here. Now, if we look at Kelly and z-score for mass, so again, we follow the same path. So we get z is equal to, now she got 66 minus 62 over 6.8. Now, if we find that, we actually get 0.588. Now, if we were to draw that on the same one here, we'd know that it's actually just a little bit higher. So that'd be the 0.588 than the 0.490. So what this means is that Kelly's z-score for mass is 0.588 standard deviations above the mean, where in history she's only 0.490 standard deviations above the mean. So we can then finish off this question by saying, therefore, Kelly's result in mathematics, was better compared to her class, even though her percentage was lower. I missed it. That should say was lower. My brain was going quicker than history. And you could go on to say because her z-score was higher. So it's always good to kind of finalize these questions, especially when there's a scenario with a question, with a sentence kind of finalizing your answer. Now, these ones are using technology. So if we wanted to do A, if we were to just sketch it out, because it's always good practice to sketch it out. So we've got 0 here, negative 0.41 and 0.67. So we're finding this. So if we use our calculator again, which we should all be good at now, so our lower is going to be equal to negative 0.41. Our upper is going to be equal to 0.67. And our standard deviation is 1 and our mean is 0, because that's always the case for standard normal distributions. And so we should get that the probability of negative 0.41 z 0.67 is equal to, and you should get on your calculator, 0.408. And I hope that makes sense. Now, I don't think in this video I need to go through B and C. You should obviously just know that if we're going Z less than 1.5, so in that case, lower is going to be negative 10 to the 99, and our upper is going to be 1.5, whereas in this one we're going to have lower is going to be, and I should have done equal signs there, be equal to 0.84, and the upper is going to be equal to 10 to the 99. And that's what you need to do to go and find those. Obviously, the standard deviation and the mean are always going to be that. But I hope that makes sense on how to do these questions. Now, these are the questions at this stage we're going to have in class. Things might change, but I think this will be fine. If you've got any questions at all, or you're unsure about what I went through, feel free to flick me an email or come and have a chat in class. Thanks, guys.